Welcome to today's webinar, Getting Started with Amazon Redshift. Our presenter today is Greg Kairala. Greg is the Business Development Manager for AWS. Today with us, we also have Sushim Mitra and Zach Christofferson. They're webinar moderators who will be engaging with you and answering your questions throughout the webinar while Greg presents. Greg, welcome. The floor is now yours.
Great. Thank you and welcome everyone. Today's topic, getting started with Amazon Redshift. This in terms of agenda, we're going to go through some basics around the positioning of Amazon Redshift and where some of the basics in terms of where it makes sense for your use cases, then talk about the benefits, follow up with some details on the use cases, and then go into Q&A. So first, before we dive into specifics on Redshift, I think it's important to understand where Redshift fits in terms of our Amazon Web Services big data portfolio. So I think the basic framework should appear familiar to most people in that we have to collect data, store it, and analyze it. And Redshift fits within the space for data warehousing and analytics within our Analyze section, but there are a number of different services that can augment the collection and storage of data before we get to the analysis. And so from an AWS managed services perspective, we have many ways of getting data into AWS, such as Direct Connect, which provides a dedicated connection into our AWS regions globally, or import-export using Amazon Snowball, which allows up to 80 terabytes to be sent via mail directly to our regions, particularly useful for data warehouse migrations. And then for streaming data, we have Amazon Kinesis Streams, which allows you to hook Kinesis to your Internet of Things or remote devices to be able to stream data in. We also have automation through Amazon Kinesis Firehose that allows you to directly connect into common targets such as S3 and Redshift to be able to enable streaming data into AWS. Of course, there are many other ways to collect data in terms of third-party tools, tools you might be familiar with using in your data center today. So this is not meant to be an all-inclusive listing, but just give you a sampling of some of the native AWS services to assist that use case. As well, if you see at the bottom, we have a service called Amazon Database Migration Service. This allows you to not only go from your database of choice, such as MySQL on-premise to MySQL in AWS, but in the case of Redshift, we recently launched support to be able to go from Oracle and Teradata databases directly into Redshift. So once I've established my pattern for collecting the data, I then have multiple ways to store the data, whether it's a file, if it's a file, a transaction, or a schema. And a file, a transaction, or an object. And so oftentimes Amazon S3 becomes a landing place for data across multiple ways of ingesting it. And then from there, we can then choose to load it into Redshift or some of our different services. If it's a transaction, of course, I might be able to use Amazon Relational Database Services or our Amazon Aurora, which is our MySQL compatible database built for the cloud. Obviously, from a streaming perspective, Amazon Kinesis is the preferred way to collect stream data into AWS. And so by thinking about S3 really as the landing place for this data, I then have the choice of the analytic tool that makes sense for my use case. So Redshift fits in, as we'll discuss today, in terms of data warehousing and SQL-based analytics, but we have other tools such as Amazon Elastic MapReduce, where perhaps you might want to transform the data using a Spark job, for instance, or your own tool set that might be living on Amazon EC2 in coordination with visualization tools such as Amazon QuickSight, which is our new business intelligence service. But of course, we have a wide variety of business intelligence partners such as Tableau and others that you can connect directly to Redshift as well. So this hopefully just provides a context of where Redshift fits in terms of our overall big data portfolio, knowing that a data warehouse in itself is not the ultimate solution that business users require, that there's often a set of services that are in conjunction with our data warehouse to be able to provide the full solution. And there's many choices in terms of different services that you might select to fill out that ecosystem around the data warehouse itself. So once we kind of provide a little bit of a context, I just want to dive right into Redshift. If there's interest on some of those other topics, such as ingestion through Amazon Snowball or using QuickSight for business intelligence, there will be separate sessions and material on our website to be able to dive deep on that. But today's topic is really around Redshift. So if I were to describe Redshift in a few bullet points, which will summarize, I think, some of the discussion we'll have later, first is that it is, in fact, a relational data warehouse. And by this, I mean you establish tables. The tables have relations between each other. And the primary language that we use to interact with Redshift is ANSI SQL. So any kind of tool set that you might have or visualization tool that knows SQL, where I want to do joins across data sets, Redshift becomes, a really great use case. And, in my background, I spent a lot of time in data warehousing industry. And I think what differentiates Redshift, of course, you'll see in the blue of calling it out, is that Redshift is a lot faster, it's a lot simpler, and it's a lot lower cost. And we'll go into some details behind each of those 3 points. So now that we've set the stage that Redshift is a relational data warehouse, let's discuss some of its key characteristics in terms of being able to deliver performance. And by performance, I mean if an analyst has a question, how quickly can they get the answer to that question? And then how can I scale out? So, Redshift by itself, as we'll get into the architecture, is a massively parallel processing system and allows me to start very small. So the smallest instance type is 160 gigabytes and seamlessly grow with multiple petabytes. And so, of course, not all data sets start at petabyte scale, but we do allow you to start small and grow as your data requirements need without having to pre-purchase hardware or pre-planned capacity. You can simply increase the size of your storage or compute to be able to meet your analytic workloads. So thinking about that idea of being a data warehouse, faster, simpler, cheaper, as a massively parallel processing allows me to horizontally scale, but then also uniquely with Redshift, it's fully managed. And by this, and we'll get into some details on this, but essentially we call it the undifferentiated effort of database administrators, where you're not necessarily adding value to the analytics, you're not delivering new and innovative solution sets, but a lot of times DBA tasks are comprised of super critical skills like backups and patching and replacing hardware and defining storage to go with our data warehouse. And all of these things are managed now for you with the Amazon Redshift. And so from a database administrator perspective, you're really focused on how you can add value in terms of defining new and innovative data schemas, being able to deliver faster performance from the application level, and not that undifferentiated effort of day-to-day storage and patching and backups and high availability planning, which are super critical to take into account, but don't necessarily result in more innovative answers out of the data warehouse itself. So just to kind of continue on our summary, Redshift in itself comes in 2 different instance types for magnetic and SSD. So depending upon your workload, if it has a high I/O requirements, or if it's more tuned for cost optimization, and we'll get into some pricing differences, but we have a choice of platforms for magnetic and SSD workloads. And then if you look at the tagline that kind of backs up the cost effectiveness, Redshift can be as low as $1,000 per terabyte per year for a full data warehouse workload. If you compare this to some other data warehouse solutions in on-premise world, those typically are in the range of $40,000 to $50,000 per terabyte per year. So this kind of speaks to some of the cost savings that you can recognize by adopting Redshift as your data warehouse platform. So if I think about the Amazon, the view of data warehousing and kind of who's been adopting Redshift, and I think these are kind of some broad buckets, but I think they're representative of the use cases that we see customers adopting Redshift for. The first is kind of for the enterprise, and enterprise just means most customers that have a data warehouse today. So kind of a broad interpretation of enterprise, but these are people that are running, on-premise data warehouses from, the vendors we probably all recognize, some of their names like Oracle and Teradata and IBM Netezza, and kind of this typical landscape of data warehousing that's been around for decades, really. And what attracts them to Redshift is, it can be up to 10 times less expensive than your on-premise data warehouse, easier to provision, and you have higher DBA productivity because of the managed nature of Redshift itself. And so this has been a huge driver for customers with a data warehouse on premise to be able to migrate to Redshift. And we have a number of examples I'll go through at the end, but this has been an increasingly popular trend where fundamentally business users are familiar with using SQL compatible business intelligence tools. So we don't want to make a change at the visualization layer, but essentially lower the cost and get better performance out of the data warehouse itself. The second area is talking about customers with big data. In this case, big data really refers to, in traditional data warehousing, because it was so complex to set up and provision, and it was really cost prohibitive, that all the data could not be loaded into the data warehouse just simply because of the cost or scale of complexity. And so oftentimes customers that still have that end requirement of SQL-based analytics will be able to leverage Redshift now because of its cost effectiveness and the fact that it's a managed service. And so if you look through some of our presentations from other presentations or other webinars we've delivered, you might see a use case with Yahoo, where the Yahoo mobile team is actually leveraging Redshift and moved away from a Hadoop-based system because of the performance gains and the nature of the analytics being through SQL. So that's kind of the second category of customers with big data that traditional data warehousing was never available, or they are more startups where they needed to establish a new data warehouse. The third one then is customers that are actually building an application on AWS and want to embed analytics as part of that overall solution. And so this is really where the end result is software as a service, such that their end customers might not realize they're using Redshift behind the scenes, but now they have great, innovative, performant analytics that are being delivered as part of that application. And so generally, these are the three different areas, both of migrations from enterprise, where they have a data warehouse, customers that have increasing variety, velocity, volume of data, and want to essentially still use SQL-based analytics, and customers building software as a service to embed analytics into it. So just in terms of third-party validation, so if you're kind of curious, Amazon Redshift has been a commercial product through AWS for a little over 3 years now. And if you look at the latest Forrester Wave report, at least from the Q4 of 2015, you'll see that Redshift is considered a leader, right? And there's some great details in this report. I definitely encourage everyone to take a look if you haven't seen this, and just speaks to the number of customers and broad adoption that Redshift has. And if you think about the period of time that Redshift has been commercially available, it's essentially right up there with other options in the marketplace that have decades of experience, and it really just speaks to the broad, deep adoption of Redshift, as well as our ability to really solve complex problems for our customers through Redshift and through data warehousing. So here's just a quick overview of some of the customers and use cases that are actually leveraging Redshift today. And I think what's interesting is that you'll see a nice mix of everything from customers we say were born in the cloud, meaning that their original business was designed and built for cloud scale, such as Pinterest, all the way up to traditional enterprises such as NTT Docomo or NASDAQ that have stringent requirements for access control, auditability, that live within a regulated environment. And there's a full spectrum in between. And not insignificantly, Amazon.com actually is a tremendously large user of Amazon Redshift. So we actually leverage Redshift at scale internally as well. And there's detailed case studies on our website to go through each of these. So that's now we kind of set the stage in terms of the market that Redshift addresses in terms of data warehousing, some of its basic benefits and customers. Let's dive a little bit deeper into what Redshift actually is. And so when I establish a Redshift cluster, you'll see that I am presented with some choices in terms of the number of compute nodes, which are direct attached storage to where I combine the compute and storage to be able to bring the computational power directly to the data itself, as well as some options in terms of defining backups and integration with other tools such as DynamoDB or a relational database service. But to the outside world, kind of thinking about this idea of a leader node, this is really what stores the metadata about the cluster. So you don't explicitly provision a leader node, nor do you pay for the leader node. But essentially, it's the store of the metadata as well as the optimized query plan. And then SQL clients connect to the leader node, so there's no direct access to the compute nodes. And to the outside world, from a leader node perspective, to your BI tool, to analysts that are just connecting directly through a SQL prompt, Redshift appears as a Postgres database. Now, of course, internally, Redshift is not necessarily Postgres. It's essentially our own Amazon innovation in terms of distributed data warehousing. But in order to maintain compatibility with third-party tools, any kind of Postgres, ODBC, or JDBC driver would be able to connect to Redshift and get analytics pretty seamlessly. And then from a compute node perspective, I mentioned this earlier, whether I start with just a small handful, like in this picture 3, all the way up to multiples of compute nodes. And I can start with the computational power or the amount of storage I need today and seamlessly scale to what my requirements are tomorrow without having to pre-purchase that. And the nice thing about the massively parallel processing architecture that Redshift delivers is that we parallelize and distribute not only queries, but also loading data. So oftentimes S3 is really the staging area for our data, and then we can parallelize the load directly from S3 into our compute nodes to be able to not only get super fast performance from a SQL endpoint, but also equally impressive performance from a data loading perspective. And then our backups are continuous and automatic, and those backups also go to S3. And so you can leverage the 11 nines of durability for your backups of your Redshift cluster. And importantly, from a pricing perspective, you'll see that we do have the 2 different flavors, both the magnetic and SSDs, and we'll go through pricing in a little bit more detail. But what's nice about Redshift is it allows you to easily choose and switch between the 2. So if your use case starts off more, you want to optimize for cost with the magnetic drives, but then decide you need the performance of SSDs, you can switch between on both of those areas. And the other component around pricing is that whatever size you provision your cluster for, let's say it's at 100 terabytes, you get an equivalent amount of backup space in S3 for that same price. And so oftentimes, if you think about backing up your data warehouse, it could be another significant increase in cost, whereas with Redshift, I'm able to define a single point and a single price point, not only for my data warehouse, but also for my backups. And of course, if you exceed your backup size, so let's say if I have 100 terabytes provision, but for some reason I need to use 110 terabytes for my backups, let's say I'm storing manual snapshots for regulatory requirements, I only pay the S3 charge for the excess capacity of the backups themselves. So let's just kind of go through a few ideas in terms of the benefits that Redshift can deliver. So we talked about the architecture at a high level, comprised of the leader node and individual compute nodes. The compute nodes come in either magnetic or SSD, whether you want to optimize for performance or for cost. But then, one of the benefits beyond just Redshift being a massively parallel processing data warehouse is that it's super fast, and we deliver fast performance by dramatically reducing I/O operations. And so the first thing to realize about Redshift is that it is a columnar database. And what this allows is that for analytic workloads, oftentimes queries are across columns, and I want to take advantage of pruning columns that only are a part of the query itself. And so this is particularly advantageous if I have wide tables where, let's say if a table has 12 columns, but my individual query only is asking for 3 of those 12, I only read the I/O that are associated with those 3 columns, and I can skip the I/O even though it's part of the table. So this is a significant advantage over traditional row store databases, the fact that Redshift is a columnar database in addition to its MPP architecture. And then because it's columnar, and the data types within the column are similar, you could take really great advantage of compression. And so knowing that, of course, the more I compress the data, that means the less I/O I have to do to read that data, which directly translates to faster query performance. And so this combination of compression and columnar storage is really important to be able to drive significant performance gains over traditional data warehouse architectures. And then let's talk a little bit about the block size first within Redshift. So we have a 1 megabyte block size, meaning that each I/O operation reads 1 megabyte of data. We take advantage of the columnar storage and compressing that, so we're trying to fit as much data as possible into that 1 megabyte, and each column is a separate file. And then we have a concept called zone maps. And so you could imagine that I'm reducing I/O through columnar storage, through data compression. But now I want to look in terms of the actual values stored within each block of data. And by Redshift automatically maintaining a concept called zone map, we maintain the minimum and maximum value within that 1 megabyte block of data. And so the Redshift optimizer can skip over data blocks that could not contain the result that we're asking for it. And so I think zone maps are pretty popular in MPP data warehouses, but again, with Redshift, it's automatic, and you can essentially reduce I/O, meaning skipping data blocks, because the database optimizer doesn't have to physically read that data to get the answer to the query. And then, taking advantage of direct attached storage is really important and oftentimes overlooked advantage of Redshift. And so if I had data, let's say, sitting on some kind of other storage mechanism, I have to go through some kind of I/O channel to be able to deliver results. This particularly becomes not only important from a query response time, but also for joins. So I want to join large tables together. It turns out that direct attached storage is by far the most effective way to be able to deliver performance for SQL-based analytics, particularly where joins and I need to have the computational power directly attached to the storage itself. And so that really drives the architectural decision we made with Redshift to stick with direct attached storage. So the next one to talk about, kind of building upon this idea that Redshift is fast, is that we parallelize and distribute not only the queries, but also loading. And so whether I have 3 nodes in the cluster, 5 nodes, 10 nodes, 100 nodes, the Redshift optimizer will distribute the query to the appropriate compute nodes to be able to take advantage of full parallelization. And the same thing from a data loading perspective, I don't have to have or go through a single bottleneck for loading data. And so we have many customers that load several hundreds of terabytes of data or several tens of terabytes of data per day into Redshift by taking advantage of this parallel nature of loading data directly from S3. And then, of course, I can export data, so I can unload data to S3 directly. And then the backups are automated with Redshift, as I mentioned. And so oftentimes this is a surprise to administrators that come to Redshift from a traditional data warehouse tool set or database background where they look for options for backing up. And of course, with Redshift, backups are automated. And so it's just something that happens in the background that goes to S3 to be able to restore or be able to recover from a backup or create a new cluster from an existing Redshift cluster by leveraging the 11.9's availability of Redshift, or sorry, of S3, really speaks to kind of the value for those undifferentiated tasks such as backing up, which are still really critical to think about. And so if I did need to restore from a backup, I can just restore it directly from S3 into a new cluster. And particularly in data warehousing where sizes can rapidly increase, we have a unique mechanism such that we restore the metadata to the leader node first, and then stream the data from S3 into your new cluster. So regardless of my size of my cluster, I can fairly rather quickly start querying it, knowing that as we're streaming data from S3, if I have a query that asks for a data block that has not been fully recovered yet, that individual query might be slower, but the rest of my queries can continue to operate as normal as we stream the restore back into the cluster. And so not having to wait for the full data set to be restored from S3 is a really great advantage for doing a restore from an existing backup. And then similarly, as I mentioned, the idea of resizing a cluster. So I don't have to do a tremendous amount of work of pre-planning for future capacity because Redshift allows you to resize an existing cluster to meet your needs tomorrow and only pay for what you currently need. And if you need to increase storage, or in some cases, you might even need to reduce the amount of capacity available to your cluster for cost optimization, Redshift allows you to seamlessly do both. So, kind of diving a little bit deeper on the benefits of it being fast, on the hardware side, the hardware itself is optimized for I/O intensive workloads. And this really is what drives data warehouse performance, is the throughput that the system can deliver, and throughput directly translates to I/O performance. So we talked about it being a columnar database, and concept of zone maps, and pruning columns from the nature of columnar database really reduces the I/O, so that we kind of want to shrink the amount of I/O as much as possible. At the same time, we want to provide a large enough pipe for that reduced I/O to go through, and this really speaks to the hardware optimizations that we have driven into the platform itself, as well as enhanced networking and the choice of storage types to be able to define the right architecture for your use case, whether you want to optimize for cost with the magnetic drives or performance with the SSD drives. And then we're on a regular cadence of automatically patching your cluster. And so generally these are every 2 weeks. And the benefit is that as soon as we have a new innovation or a new enhancement, you can almost immediately take advantage of that. And the managing of the patches is something that becomes now part of the Redshift service itself. And you can take advantage of those benefits rather quickly. And so here's just an example of some of those benefits that we've delivered over the past year or so. So we launched a new dense storage type, and essentially doubled the compute, doubled the memory, and almost doubled the disk throughput, all at the same cost as the previous generation. So as you can imagine, as our friends at Intel continue to increase the processing power, and things like network and storage continue to improve, you can almost immediately take advantage of those improvements in your existing data warehouse with very little change, and being able to essentially pay the same cost for up to significant improvements in terms of query response time by taking advantage of that new hardware, all for the same cost, has been really beneficial to our customers. And from a software perspective, as you can imagine, like any database, we're constantly working to improve performance, reducing I/O, and things like memory allocation. And so a number of these patches have come out recently in the past 6 months. And there's been some blogs on the AWS Big Data blog that talks in more details on these. But essentially, we can think about improving, almost doubling the performance just from a software perspective by taking advantage of these new patches that we've released into the Redshift cluster itself. And we're constantly evaluating ways to continue to improve performance, reduce some of the administration side of Redshift from a tuning perspective, as well as delivering better performance for our customers. Okay, so now we're on to the second benefit. So we've been talking about the cost of Redshift and putting it in comparison. So it's important to note that Redshift itself, you pay by the hour based upon your instance type and the number of nodes. And then to make it a little bit simpler, because so many data warehouse vendors provide their cost based on per terabyte per year, we provide a mapping from that per hour charge into that more commonly used per terabyte per year metric. And so if you think about our dense storage type, which again is a magnetic disk-based, an on-demand perspective, it can be about $3,700 per terabyte per year. And this is really great when you're just getting started with Redshift, and so you're doing a proof of concept, or you want to test out, does Redshift make sense for my use case? So you can do your testing. But then immediately, let's say if you wanted to say, okay, this makes sense, then the nature of database workloads is that they are usually going to be on 24/7, right? Particularly the global nature of business today. And so this is where it makes sense to take advantage of some of our discount pricing structures called the reserved instances. And so depending upon your level of commitment, whether 1 or 3 years, this is where you could start to see significant discounts off the on-demand rate. So if you look at the 3-year reservation for our dense storage type, that's where we can get less than $1,000 per terabyte per year. The same applies for our SSD-based instances. Again, you pay by the hour. So let's just say you have a very small data set, less than 100 gigabytes, that you want to start testing with. You might choose our dense compute instance type to be able to test that for 25 cents per hour. And then you can then scale that out, whether you stay in the dense compute or move to dense storage, still taking advantage of the pricing constructs of the reserved instances so that you don't have to pay anything up front. You don't have to make any kind of long-term commitments until you're ready to. But equally, kind of the opposite side of this is let's say you determine that Redshift doesn't meet your needs, or some other tool in our analytic framework makes more sense, then you can just turn your Redshift cluster off, right? And so oftentimes customers will have an idea, does this use case make sense for data warehousing and SQL-based analytics? We'll try it out. If it works great, they scale it to production, take advantage of pricing discounts to reserved instances. But equally as important, if they find that experiment doesn't work out, or they have a different tool that might make more sense, then they can just turn the Redshift cluster off without having to make any commitments to it. And this really helps drive innovation through analytics, where previously I might have made a large capital investment in a particular stack, which then a year from now or 2 years from now means that any question I ask has to go through that stack because we've already purchased it. It's already sitting in our data center. We've already made that commercial licensing of software commitment. With Redshift, it's dramatically different because now I can encourage innovation, meaning that if Redshift makes sense for the use case, I can use it, scale it up, but if it doesn't, just turn it off. And so this idea of driving innovation through analytics has become a real benefit that Redshift can deliver. So then talk about fully managed. And so I talked a little bit about the fact that backups are continuous and automatic. They go to S3. We have the ability to do automated patching, to be able to stream the restore into the leader node. But then even within a cluster itself, we automatically can maintain multiple copies of the data. And so you can imagine that in a multiple node cluster configuration, if I were to lose a compute node due to like a disk failure or hardware failure, we maintain multiple copies of the data such that your cluster might be at reduced capacity, but you don't lose any data. And so, of course, the backups going to S3 provides 11 nines of durability, but then even within the cluster itself, we replicate the data to be able to account for any kind of hardware failure that might occur in my cluster. And then also, from a regional perspective, you could imagine if there, however unlikely, a regional issue or something that might occur, you can choose to take advantage of what we call the cross-region snapshot copy. So by default, Redshift backups go to the same S3 region in which you're operating. And of course, we will never move data outside a region unless you explicitly tell us to, whether that's for compliance reasons or regulatory reasons. But if you so choose to copy your backup to a separate physical region, you could take advantage of the cross-region snapshot copy to be able to restore your cluster into an entirely new region. So there are some cases in some industries where customers maintain their primary cluster in US East, which is our Northern Virginia region, and then choose to maintain, let's call it a warm standby of that data in US West 2, which is our Oregon region for particular use cases. And this, doing it through a single API call or a single click of the checkbox in our console is really beneficial if I do want to take into account multiple region configurations. So then let's talk about security. So we talked about some of the different customer industries that are leveraging Redshift. Of course, it spans everything from government agencies to telecommunications to banking, finance, healthcare, as well as innovative startups. But across that full spectrum, regardless of your size or your regulatory environment, security is always a forefront consideration. And so the fact that you cannot physically connect to the compute nodes, that they reside within a virtual private cloud, and that they are segregated and isolated from a VPC perspective provides the first level of assurance. And then you have the option within Redshift to actually encrypt your data. And so at the start of the cluster, I can choose encryption. We have multiple ways to manage the keys, whether it's through Amazon Key Management Service or Cloud Hardware Security Module, or even an on-premise hardware security module in terms of managing the master key. You can be assured that all of your data is fully encrypted within the cluster itself. And then you can also connect to the cluster through SSL so that you can have a secure connection into the cluster itself. And so from a auditing perspective, of course, we know that we want to be able to track and maintain any kind of changes to the database. So in addition to encrypting the data, any kind of schema change or any kind of administrative action can also be audited and logged and can combine with CloudTrail to be able to store those audit logs out into S3 if necessary for complete audit and compliance reporting. And then from a third-party validation perspective, Redshift has done extensive validation through SOC reports, SOC 1, 2, 3. It's available for PCI data, as well as ability to store U.S. healthcare information through signing a business associates agreement, as well as for U.S. government agencies, it's been through full FedRAMP audit. And so there's a number of these. If you're not familiar with all of these terms, essentially it's just saying that Redshift security has been thoroughly audited and evaluated by third parties, and so we're very confident that Redshift can meet your audit and compliance needs regardless of the industry or the region in which you operate. So talk about benefit number 4. So this is the fact that we innovate quickly. And so you combine this with the automated patching thing and features that we mentioned, and the fact that every 2 weeks, essentially, we're pushing out incremental changes to Redshift to continue to drive better performance, better availability, better throughput. And so this might be a little bit of an eye chart, but just kind of speaks to how quickly we're innovating and changing the Redshift platform to adapt to new and emerging analytic needs that our customers are challenged with. And then, next, benefit number 6 is that it's powerful. And so I've really been emphasizing the fact that Redshift is fully compatible with your SQL-based analytics. And to the outside world, Redshift presents itself as a Postgres database, but there are many cases where basic SQL doesn't meet the analytic needs of the business. And so we've continued to innovate in terms of functions that expanding the function library within Redshift itself, as well as allowing you as end users to define your own user-defined functions using Python 2.7. And so with that, you can essentially compile Python code and submit it directly to the Redshift cluster, and then allow analysts to call that Python function from SQL itself. And so there's many examples up on our big data blog about actual use implementations of this, but essentially allows you to expand the capabilities of SQL language by submitting a Python code set using common libraries like NumPy or SciPy to be able to do more advanced analytical functions, but then provide your analysts the simplicity of calling that function through SQL. And then we have many customers that want to expand into data science, and so they might be familiar with tool sets such as R or SAS or even Spark, which is not listed here. But all of those tool sets have a tight integrations with Redshift, such that your historical view, your data warehousing view, can be stored and managed within Redshift, but then extended to meet more analytic use cases, whether you're coming from a SAS environment, R, or even something Spark machine learning, to be able to integrate with Redshift for some of the data that's available. And then from a machine learning perspective, although not really the scope of today's call, we also have a service called Amazon Machine Learning that allows you to embed predictive analytics into your application. And data stored within Redshift can be easily integrated with Amazon Machine Learning to drive that predictive analytic use case. So kind of expanding upon that is, we talked about in the beginning a little bit of the AWS big data stack and different services to ingest data, to store data, to analyze data. But importantly, you also have a wide variety of third-party tools that can be seamlessly integrated with Redshift, whether from a data integration, business intelligence, or if you need help from a system integrator perspective as well. And so oftentimes, we mentioned this one of the primary use cases of Redshift is customers moving from an existing on-premise data warehouse to Redshift, and they don't have to recreate everything from scratch. And so we've got great integration with Informatica, for instance, where for the most part, not all, but majority of your Informatica jobs can remain the same. Perhaps if you're using a business intelligence tool like Tableau, you'd be able to continue to use your Tableau reports. But now your data warehouse can be essentially migrated to Redshift. And of course, it would not be a simple exercise of just pushing a button and you're migrated, but the majority of your reports and the majority of your data integration jobs could potentially remain the same. But now you're using a much more cost-effective and performant platform in the case of Redshift. Or if you're developing something new, you can still leverage some of the great innovation that our partners are delivering, both from data integration and visualization perspective, and then leverage some of our partners to help design that next level of analytics and data warehousing. And so the fact that Redshift had a large number of partners should really provide assurance that we can meet your need for your use case based upon the tools that are most familiar and most comfortable to you, without having to force you into a particular solution stack. And then rounding that out and kind of accelerating on that is that because of the on-demand nature of Redshift and just AWS in general, it really drives this idea of a service-oriented architecture. And by this, I mean a data warehouse is just a single component of an overall analytic framework, oftentimes used in conjunction with a transactional database, a non-relational database, or a visualization or ability to capture streaming data. And all of these services can be combined to create an overall solution for a particular set. And my personal background is I came from Oracle, and oftentimes, it was simple from Oracle perspective that we would use the Oracle database to be able to do multiple different tasks, such as transforming the data, storing the data, being able to capture not only analytic workloads, but also transactional workloads, which is still, not saying that pattern is wrong, but now think about AWS and our solution offerings around big data. It allows you to segment out those into a more cost-effective and more scalable mechanism, such that we might not choose to use the Redshift database engine itself to do all the transformations, but we might leverage Elastic MapReduce, our managed Hadoop service, to take advantage of the on-demand nature of Hadoop clusters to do the transformation of the data. And so these architectural patterns are constantly evolving. We do a lot on our AWS Big Data blog to help simplify some of that, as well as work with our system integrator partners. But really, this toolkit really can provide a powerful tool set for innovation and moving beyond just keeping the lights on for analytics from a traditional data warehouse perspective. By leveraging some of these services in conjunction with Redshift can really drive to the next level of analytic workloads within your organization. So here's a couple of the launches that we've recently put out for Redshift. So I think I've talked about a few of these on a previous slide. So I'm not going to go through each of these, but as any database platform or data warehouse platform you can imagine, we're constantly working on performance and ease of use and adding security functions and expanding our analytic footprints, as well as, I'll just spend a second here thinking about this service-oriented architecture and extending and making it more easy to get data into Redshift. Our database migration service has now extended support for Redshift such that if I'm using Oracle, SQL Server, Postgres, or MySQL, I can now easily leverage our database migration service to get data into Redshift, as well as our schema conversion tool, which will assist with the planning and conversion of an existing data warehouse into Redshift. Now supports Oracle and Teradata to be able to assist if it makes sense to migrate into Redshift for your use case. So just talk about a few of those use cases now. I just want to go through a few examples. So the first is NTT Docomo, kind of at scale. So if you're not familiar with them, they're one of the largest telecommunication providers in Japan. So millions of customers, large, 6 petabytes of data. When they had essentially a Greenplum data warehouse on-premise, that they had a lot of scaling problems, performance issues, but their requirement was they wanted to maintain the same level of security and need a hybrid environment, meaning that their core transactional systems were not going to move to the cloud immediately. So the data warehouse from Redshift had to seamlessly integrate with their on-premise environment. And here's just a high-level overview of their architecture. And so they're able to leverage Direct Connect, multiple Direct Connects actually, to keep the majority of their infrastructure on-premise the same, but now adopt a significantly 2 petabyte data warehouse using Redshift while still keeping their BI tools on-premise and being able to deliver faster queries at a significantly lower cost with significantly less operational overhead by taking advantage of the managed service. And so we like to talk about this use case a bit because it really speaks to the scale at which Redshift can operate at while meeting regulatory requirements for telecommunications industry. The next one I'll just kind of highlight quickly is NASDAQ. And so what's interesting about NASDAQ is that they essentially had a similar problem in terms of their existing data warehouse was expensive. They had to make large capital investments, but they really wanted to reduce their cost of the data warehouse while maintaining a strict security and regulatory requirements that U.S. financial services industry mandates. And so by selecting Redshift as their data warehouse, they're not only able to reduce their cost by by 3/4, so just 1/4 of the cost of their existing data warehouse, but still maintain the strict compliance and security in terms of encrypting the data, being able to connect securely to the data, and being able to deliver fast and great performance to their end users, and being able to do this full migration from their previous system in 7 man months. And so they had a couple of people, I believe it was about, total project was around 3 months to execute. And if you're curious in terms of more details on the NASDAQ use case, there was a presentation 2 years ago, so I believe it was 2014 reInvent, where some folks from NASDAQ went through about an hour presentation going through the details of their actual migration. But we just kind of brought those up just to highlight a few of the interesting use cases where customers have migrated from significant on-premise data warehouses to Redshift in a relatively short time frame, but were able to not only meet their regulatory requirements, but deliver significant cost and performance savings. So that's kind of the end of our overview presentation. I want to provide a little bit of resources for folks. My name again is Greg, and there's my email address. Happy to, if you have any questions, please reach out to me. If you have interest in terms of a little bit more detail on some of the use cases or some of the partners that Redshift can support, we have the detail pages. And then importantly, if you want to get started with Redshift, it's very simple to get started, to load data. I would encourage everyone, though, to just spend a few minutes reviewing the best practices documentation in terms of data loading, table design, and query performance, just so that as you get into Redshift and start using it, you have a little bit basics in terms of the tips and tricks of getting maximum performance from your cluster. So that's the end of our talk. I think I'll turn it back over to our moderator for a quick announcement, then we'll come back for questions.